So again, this video is going to be part showing you how to navigate digits and part giving you answers that you need to be writing in your student companion for digits. So just to be sure, we should open to page 131 in your digits student companion, and on your computer you should have open your haiku page. We're always going to start logging into Gmail to haiku and then access through haiku. Over here you'll see on all the pages log into digits, and what I want you to do is right click this and say open link in a new tab, and up here you'll see it pop up. This is going to take you to, this new tab is going to take you to the place where you need to log in, and I want you to do that right now. So mine's already logged in. I need to take time to do that now. So pause this video here on haiku and go to digits and log in. So once you've done that, you should have open on your browser a tab that is this video and a tab that is your digits little portal. So as always, we go to do. So take time now, go to do. And today we're going to do lesson 6.2. So we're going to go down here and we see the little skittles up above, the digit skittles. We say lesson 6.2, and you should see a start button. And it will pop up in another window like this. So right now take time to do all of those and come back to this. So just clear, you should have one open with 6.2 and two tabs open on browser, one of your haiku page, one of your digits page. Most importantly though, you have your haiku page and this window open right here. So we're going to go to the launch. It says 2 runners run a 100-yard dash at speeds shown in the diagram. Runner 3 starts 4 seconds before runner 2. Will runner 2 pass runner 3? Tell how you know. So now we're going to record our on page 31 of our student companion. I'm going to give us room to work it out. And we had a previous problem like this already where 2 runners were going at different rates. But if you notice here, this runner here is going at a speed of 8 yards a second, and this runner here is also going at a speed of 8 yards a second. So page should look something like this. Again, it's page 131. You need to write a little explanation determining whether or not these runners will cross paths. So let's think about this. Runner 3 starts 4 seconds before, but he's going the same rate as runner 2. Will runner 2 ever pass runner 3? No, because by the time runner 3 is here, runner 2 will just come 4 seconds after that because they're going at the same rate. So the answer to this question is no. Runner 2 will never pass runner 3 because they are running at the same rate. They are running, excuse my extremely sloppy handwriting, at the same rate. So this whole section is about thinking about whether or not you need to set up a system of equations for this like we did last time, or if you can just inspect it and figure out that no, obviously these two are never going to pass because they're going at the same rate. So down here in the reflect it says, do you need to set up a system of equations to solve this problem? Explain. And you can say no because we just kind of talked about this. No. We can investigate the problem, without solving to determine the answer. And you're going to try to do this on a lot of them today. So those of you who don't like to show a whole lot of work, you might be happy with this section. So now we're back on the little window, the little digits window, and we've done the launch. Let's go to slide number 3 of the launch. Click through to slide number 3. And it gives us our focus question. How can you find the solution of a system of equations just by inspecting the equations? Well, we're going to go through how we need to do that. So let's go to examples. And again, you can be watching my video for this until I tell you to go to your actual digits video to actually click through the examples. And I don't know why this is taking so long. Okay, looks like it's going to.
Hello, hello, hello. What do we have here, then? 3 types of solutions, eh? Well, this will call for fine inspecting. I'll be all over these graphs, I can tell you that for a start. I highly advise you to do the same.
Okay, so basically he just told us, he's a little detective, and he said there are some inspecting that needs to go on with systems of equations. So there's 3 solution types, and they're listed right here. The first type is one solution, and if you click this, which you should just be watching my video right now, but if you want to go back and look at it, it says one solution, the lines intersect, the equations have different slopes. For no solution, the lines are parallel, and for infinitely many solutions, the lines are the same. So what I would want you to do now is, if we go back to our page 131, I want to put those notes right here, right at the bottom of, right down here on your page 131. So for one solution, we have different slopes, and the lines intersect, and lines intersect. For no solution, the lines are parallel, which means they have the same slope. So lines are parallel, which means they have the same slope. So they have and same slope, different y-intercepts. So we can put that too. Different y-intercept. And for all solutions, or infinitely many solutions, and remember we abbreviated that like this, infinitely many, we can just put they're the same line. So once we've written those notes, I want you guys to actually go to your other window, click part 1. Once you click part 1, a page should come up looking like this. Then click this next, and you're going to go to 2 of 3. And this is where the drag and drop comes up. So what we're really determining is whether or not these have the same one solution, no solution, or infinitely many solutions. They're all systems. So this one here, you might think, oh, these are 2 different equations. Well, I want you to look really carefully at this. 2x plus 3y equals 6, and 8x plus 12y equals 24. If we divide all 3 of these numbers by 4, we get each of these numbers. Think about it. 8 divided by 4 is 2. 12 divided by 4 is 3. 24 divided by 4 is 6. So these 2 are actually the same lines. There's infinitely many solutions. This one here, you see that it has the same slope right here. X is the slope here, X is the slope here. So there's going to be no solution, because remember, no solution means there's parallel lines. Oh, look, here we have another one with the same slope, 4x and 4x. This one here has one solution. So go ahead and go to your video and click around and drag and drop and see if you can get these correct. Now, once you've done that, you should see Kamal come up here. He's dancing. And then you can go to page 3 of 3. Now, again, this is where you record in your student companion. We're now on page 132. This is the got it. Without graphing, decide whether each system of linear equations has one solution, no solution, or infinitely many solutions. So I have your student companion copied over here, and we'll go through this together. Without graphing, oh, I just read it. So, again, this is really cool. This is x minus y equals 6. Well, if I took this equation here and I divided all of it by 2, I think we should check there first. If this was divided by 2, and this was divided by 2, and this was divided by 2, I'd get x minus y equals 4. Okay, so those aren't the same. So we know it's not infinitely many because it's not the same line. But what we do notice is they have the same slope. Remember, the slope is whatever is in front of this x. And in this case, both have that invisible 1 in front of this x. So we know that there is no solution because they have the same slope. So, same slope. In this case, it's 1 equals no solution. Now that we've written that answer, we can go to part 2. And again, the little detective will pop up. And he's
What's this?
inspecting.
What?
These.
X plus y equals 8 and 25? Seems like a pretty strong clue to me. I smell no solution.
This system has no solution because x plus y cannot equal 8 and 25 simultaneously.
So basically what they're saying is x plus y equals 8. Well, then x plus y can equal 25. If we put two numbers in here, let's say 2 and 6, 2 plus 6 equals 8. 2 plus 6 cannot equal 25. So this has no solution. And we figured that out without doing any math, just by investigating. So we click the next over here, and we get 2. So by inspecting these equations, what can you determine about the solution to this system? So again, we can see, all right, can we divide this one here to get this one here? And yes, we can. If we divided this by 2, divided this by 2, and divided this by 2, these would all be the same. So if we also click solution, I'm sure it'll tell us. 3x minus y equals 6 and 6x minus 2y equals 12 are the same line because 6x minus 2y equals 12 can be written as this, which is basically just dividing it by 2. Here we have our 2. Therefore, this system has infinitely many solutions. All right, and now the next page we go to, this is what's in our student companion, page 132. By inspecting the equations, what can you determine about the solution to this system? All right, so let's go ahead and write. Y equals negative 6x plus 15, and y equals negative 6x plus 9. Well, these two systems have the same slope, negative 6. So again, same slope, and in this case, not like the one above, this case it's negative 6. That equals no solution. This means they are parallel lines. No solution. All right, last part. So we click our close and check here on our window. And again, they're going to come up with that question. How can you find the solution of a system of linear equations just by inspecting? And if we click we click solution, we'll see the answers on page 133. If you need help, please use this. Try and solve it on your own, but if you need help, use that answer page. Try and work these out on page 133. Again, here's that answer page that should popped up. This should be done by the end of class, and then tonight's homework is actually in your to-do list, lesson 6 or homework 6.2, just how you had 6.1 over the weekend. Now, if you couldn't access it, don't worry, we're not going to count it until the test. but you need to get these homeworks done so you don't fall behind. Come in after school or at lunch and see one of us to use a computer and get these homeworks done.